Welcome back, everybody. Today we're going to do a real quick lesson on density altitude.
Grab your pen and paper.
Yeah, we're going to do a little math here. It's going to be easy math, I hope. But anyway, I ask all my applicants, my privates and my commercials, I'll say, what's our density altitude today? And they'll give me a number. And I'll say, well, tell me, what is density altitude? And I normally get one of two answers, and I'm really okay with both of them. But one answer I'll get is it's pressure altitude corrected for non-standard temperature.
I like that answer.
That's the
textbook answer.
That's the textbook answer.
But do you understand it?
Right. The other answer I get is it's the altitude that the airplane thinks it's at. And I like that one too, because that kind of, from a performance standpoint, we know if it's really hot today, the airplane's not going to perform very well. So, our performance charts are based on a standard day. And standard day is really three things. First of all, sea level, standard altimeter or standard pressure, and standard temperature. So the first thing we have to do is we have to define what pressure altitude is. So what is pressure altitude? Pressure altitude is the altitude when measured from a standard altimeter setting, a standard pressure datum plane, I think people use. I don't know, fancy words. But it's what the altimeter says when we set 2992. So, I'll ask the applicant, if we're sitting in an airplane and we want to know what pressure altitude is, what do we need to do? And all you got to do is set your altimeter to 2992 and read it.
You can also calculate what pressure altitude is by knowing what the altimeter is in correlation to 2992. So
right.
That's you could
right.
math it out, or you could run out to the plane and just set 2992 and read your altimeter.
Yeah. So we're going to talk about how to calculate what your pressure altitude is, and it's really it works out really nice. For every 0.01 on the altimeter setting, it equates to 10 feet. So if we have, let's say we're at an airport that has a mean sea level of 250 feet. Let's use a nice round number, 250 feet. And we have an altimeter setting of 2993. That's 0.01 above standard. So if we dial that altimeter down from 2993 to 2992, we are going to lose 10 feet. So today, again, mean sea level 250 feet. The altimeter is 2993. Pressure altitude for our airport is 240 feet. Okay? Let's say the altimeter is 3002. That's 10 times that. So 10 times 10?
It's 100.
Woohoo! So in that case, that 250-foot airport with an altimeter of 3002, pressure altitude would be 150 feet. So I'm an airplane geek, okay? And this is what I do in the morning before I go out for check rides. I sit at my breakfast. I got my cup of coffee in my Checkride chat coffee mug, and I'll pull up the weather at our local airport, and I'll look at the altimeter setting, and I'll look at the temperature, and I will use my little way of calculating density altitude. So let's say today we'll use Conroe, Texas. That's our local airport. 240 feet is the airport elevation, real close to that 250, right? So 245, let's say the altimeter today is 3007. The difference in 2992 and 3007 is 0.15. That equates to 150 feet. So I take 245, I subtract 150, I get a pressure altitude of 95 feet. Okay, so our pressure altitude is 95 feet. Now we've got to adjust for temperature. And my simple way of doing it, and this works fairly well at more humid environments.
Locations.
Yeah, like we're on the Gulf, so we're kind of humid. So again, our pressure altitude is 95 feet in this example. And let's say the temperature is 22 degrees Celsius. 22 degrees Celsius. That is 7 degrees above standard. Standard temperature is 15 degrees. Again, remember, that's standard temperature at sea level because we're going to come back to this. So it is 7 degrees above standard. So I take 7, I multiply it by 150. And 7 times 150 is 1,050. Pull out your calculator. 7 times 150, 7 times 10 is 70, 7 times 5 is 350, 700 plus 350 is 1,050. I take that 1,050, I add it to 95.
Did you just do Common Core math?
And
all right.
I got that 1,145 as density altitude. I will then compare it to what ForeFlight says my density altitude is.
It's typically pretty good. It's within like 50 or 100 feet.
Yeah, from a percentage standpoint, it's usually
minimal.
It's usually within 10%. Okay. Now, here's where it gets a little trickier. If you are at an other than sea level airport, you've got to realize that your standard temperature goes down as that airport elevation goes up.
So let's just use Denver and call it 5,000 feet.
Yeah.
The Mile High City. Easy math. It's not, but it's basically dead at 5,000 feet. So
right.
Go from there.
So 5,000 feet, the standard lapse rate is 2 degrees per 1,000 feet. So 2 times 5 is 10 degrees. So Denver the standard temperature is going to be 10 degrees lower than at sea level. So basically standard temperature in Denver is 5 degrees. So if we have a temperature of 9 degrees Celsius in Denver, it is +4. Okay? It's not, you can't take 15 minus 9 and come up with -6. Okay? It is +4 in Denver. If you're at a 2,000 foot airport, standard temperature would be 11 degrees. So you've got to make that adjustment as well. And it works just, if it's minus, if let's say today in Conroe, Texas, it's 11 degrees, that's 4 degrees below. So 4 times 150 is 600. We would subtract 600. So just take that, throw it around, play with a little bit, and again, where it gets, the error becomes a little bit greater is at the very dry environments.
Arizona,
yeah,
Phoenix.
Yeah. Now there is a different, more complex way of doing it, but we're not even going to get into that. So that is basically a poor man's way. I shouldn't say a poor man's way, but a simple way of calculating what density altitude is. And again, going back to that less formal definition that we get on check rides a lot. What is density altitude? Well, it's the altitude that the airplane thinks it's at. So is the airplane going to perform better?
That's what I was about to piggyback. Yeah. So what Wally was saying, his altimeter settings were all 2 things to know. Altimeters, if it's higher than 2992, so if it's simply a greater number, you're going to subtract that for your pressure. So in theory, high is low. So if you go higher than 2992, you're going to want to subtract what you compute for your pressure. If you are lower than 2992, so say 2982, you're going to add that. So high is low, low is high. However, on temperature, that is the higher the higher the outside temperature, the worse your performance is going to get. Where would you rather run a mile? In 100-degree heat or 60-degree heat? It's the same with the airplane. If it's simply hotter outside, you will perform worse, just like the human body.
Right.
So it's just a couple things to kind of keep in the back of your head.
So in a nutshell, density altitude. So hope you like it. If you got comments, here are our emails up on the screen. If you're on whatever platform you are, if you'd subscribe to us, hit like down below. We would appreciate it. And we'll see you next time.